Hello, everyone, and welcome to the Electricity Canada's Conversation Series. Electricity Canada is the national voice for sustainable electricity for its members and the customers they serve. My name is Farhan Mirza, and I'm pleased to be your host for today's session. I'd first like to begin by acknowledging that the land on which I am broadcasting you from today is the traditional unceded territory of the Algonquin Anishinaabe people. The Algonquin peoples have lived on this land since time immemorial. I'm grateful to have the opportunity to be present in this territory. We'd also like to recognize Canada as the land of the First Peoples, Inuit and Métis. We'd like to pay homage to the Indigenous peoples past, present, and future that continue to work, educate, and contribute to the strength of our country. I would like to recognize that the land is shared through historic treaties, developed through contemporary treaties, and one that continues to be unceded territory. The Conversation Series features presentations from Electricity Canada's corporate partners, and the series will highlight a variety of Canadian and international solutions to current and future challenges faced by our industry. Working with our partners, these webinars have been developed to be of specific interest to those working in the electric utility space, from generation through to the customer. For a list of upcoming sessions, please go to the Electricity Canada website at www.electricity.ca. Before we get going, I'd like to go over a couple of housekeeping items. Our session today is scheduled to run from 1 to 2 p.m. Eastern Standard Time. Questions can be asked, and we'd encourage you to do so as they come to mind by typing them into the questions function on your screen, and they will be asked at the end of the presentation as time permits. A brief survey will be sent to webinar participants following the session today. We very much appreciate your candid feedback and are interested in hearing about any topics you'd like to have covered in our conversation series in the future. Lastly, please keep an eye out for future webinars and events through our monthly newsletter called Current Affairs. With over 6,000 subscribers, Current Affairs is the place to go for Canadian industry news as we connect the national value chain from generation to the customer. If you'd like to receive Current Affairs, you can subscribe to this free publication again on our website at electricity.ca. Moving on to today's conversation series, we'd like to welcome Siemens Canada, who will be talking about digital twin cloud-based testing of protected relays. The pandemic has affected our daily lives both personally and professionally in terms of moving from in-person to the virtual world. In general, it has impacted utilities and the standard ways of working. Technical staff, engineers, and field technicians who were used to working on office environments, on-site, or in labs had to adjust to now primarily working remotely. So how can they conduct testing and validations on projects before releasing into market? To go over this and more, our presenters are from Siemens Canada, Paul Lorenko, business developer, and Kabir Mohammed, business segment manager from Siemens Canada. Paul and Kabir, I'd like to welcome you both to the conversation series, and I'll turn the webinar over to you.
Hey, thank you. Thank you, Farhan, for the introduction. Hello, everybody. I hope everyone is having a great day so far. My name is Kabir Mohammed. As you can see, as Farhan introduced, I'm the head of sales director for Siemens Canada. I'm responsible for the protection and control substation automation business with Siemens Canada. I've been with Siemens for about 5 years, or about 5 years, and part of the Siemens infrastructure division, which has a business unit called electrification and automation. Together with my colleague today, Paul, I welcome you all once again to this Electricity Canada Conversation Series webinar on digital twin, the cloud-based testing of the protective relays. Next. Yeah, before I begin, maybe if you go to the next slide. Yeah, I just wanted to touch base and give you a little bit about what is Siemens electrification automation business does. As you can see here, this portfolio, this business offers a complete range of elements from electrification, automation, and distribution markets, and act as an enabler for future growth. So if you look at this slide, you can see the markets it covers, from DSOs, TSOs, data centers, energy-intense industry and transportation. The portfolio, some of the key elements in this portfolio, which I belong to, is protection and control, medium voltage in primary and secondary switchgear, low voltage boards, motor control centers, bus bar trunking systems, e-houses, prefabricated e-houses, digital and classical services, which also include a complete full portfolio of the distribution systems. And of course, it does include the IoT offerings as well. We have the photovoltaic centers, inverter systems as well. We have factories across 26 countries across the globe. We have more than 100 plus nationalities working in this. We have about 12,500 customers worldwide, and we have 15,000 employees working for Siemens Infrastructure, Electrification, and Automation Division. Next. So, these are I would call them the current mega trends. As we know, the markets are becoming very dynamic. We all know we are in the middle of a major transformation happening as we speak. If I talk about transformation, we're talking about 3Ds, we're talking about decarbonization, decentralization, and digitalization. And one such trend is the digitalization. Obviously, as Farhan alluded to, this pandemic has pivoted the digital transformation journey much faster to the market than we have anticipated. And the reason is pretty plain simple. As we all know, in the pandemic, people are working more remotely, moving from in-person to virtual world has become a sort of a norm. And many of the vertical markets, be it utilities, industries, have the staff, engineers who have to adjust and adapt to this new normal. And this exactly brings us to the topic, which is a very key component in this today's world. So next slide, if I go to the next one. Yeah, and if you can see from this slide, we have a major chunk of our offerings, and we will be focusing today on the IoT side of the digital twin, which is exactly in line with the digitalization journey we are talking about. And here, if you go to the next, this focus today would be on the digital twin, and I will probably play in a video for you. But before that, I want to give a quick highlight, a quick overview of what exactly digital twin is. Right. So using the power of IoT, the Internet of Things, we are now able to test the engineered virtual twin of the protection relay directly in the cloud in a parallel setup without actually using additional hardware. So this digital twin solution can definitely shorten the time in field in operation, and thus obviously lowering the cost of ownership. Needless to mention, it helps us to tackle the unforeseen topics because obviously we can do a design before investing on any hardware. We can do it in a way which is useful for you before going to the site, and obviously reducing the resources of putting together to test the devices and able to put a plan. You know what I mean when I take you to the next slide, when we will give you an overview with a brief short video to explain to you what I mean by digital twin. And with this, I will ask Paul Lorenzo to see you on the other side of this video. I will take you through a little more detail on what we mean by our Ciprotech digital twin and how it enables a digital journey as we work towards it. All right, Paul, thank you. If you can play the video.
This is Tom and his twin brother Mike. Just like all human twins, they seem to be identical to us. In fact, however, human twins are never 100% identical. And how is it with digital twins? With Ciprotech 5, a digital twin is the digital one-to-one image of a real device with exactly equal functions and exactly equal behavior as the original Ciprotech 5 device. For that reason, you can now test the functions and behavior of a Ciprotech 5 device even when you have no access to this device. For example, during engineering or during disturbance analysis. Instead, you use the Ciprotech digital twin, and that at any time and from anywhere, because the Ciprotech digital twin is located in the cloud. This creates new opportunities, reduces costs, and basically works quite simply. You export the device data from DigC5, you establish a connection to the cloud, you upload the device data into the cloud. You are working with the Ciprotech digital twin as if it were a real device, and that with your system data, with your test scenarios, with your parameter settings, And all, of course, according to the highest cybersecurity standards. Here are some specific examples. Validate the protection and automation functions of a CPROTEC 5 device. Test the Goose communication between two devices. Or check the communication interface to the station automation. For all that, you merely require a PC or notebook with any browser you like. And then, connect, log on, get started. This is easier than a test setup, faster than driving to the plant, less expensive than the investment in test devices. The CPROTEC Digital Twin is an innovative all-round package from which you can derive the maximum benefit. Validate your application with virtual devices before you buy real devices. Test self-made functions immediately on the appropriate CPROTEC Digital Twin. Reduce the commissioning time through advanced testing of the virtual plant. Train employees with the virtual device suitable for the respective application. Or simply find your own individual benefits with the CPROTEC Digital Twin.
Okay, so I hope all of you all could see the video. My name is Paul Renzo, and that was a pretty informative session on the Supertech Digital Twin. So before diving into any of the further slides, I would like to have a poll question now, and I will keep the poll question on for about 30 seconds, and then we'll look at the results of the poll question. So I hope you can see the poll question. And the poll question is, what are your main challenges when it comes to engineering, testing, and commissioning? You have four options, and the four options, you can choose any one of the four options or all the four options. And I'll wait for about 30 seconds, and then we'll look at the results. Okay, so we should have the results. Okay, so we have 29% of the attendees suggesting that multiple relays, test sets, and tools resulting in space consumption is a challenge. We have 43% of the attendees mentioning that time consumption due to wiring creating a setup is a challenge. We have 29% respect for 29% having a challenge for training requirements, and for safety, I do not see anything for safety. Okay, so thanks for letting me know about that. I hope you can see my screen now. So you should be able to see my screen. Back to, let us look at a short video on digital twin. I hope that was informative, but let's go further ahead. So based on the results, I hope you can see my presentation. So based on the results of the poll questions, we have identified some challenges we face today when dealing with physical protection relays. So on the right-hand side of the presentation, I have compiled a summary of challenges faced by multiple customers all across the globe. As you can see, customers face issues with multiple physical protection relays and test sets. And why does this happen is because each protection relay is desired for some particular type of application, like overcurrent or some other application. So if you want to have different applications, you need multiple relays. When you have multiple relays, you need a large space because you need to keep the relay somewhere. You consume also a lot of time when creating a setup, and that includes wiring and arranging the wiring and the power supplies and the devices. Also, a few challenges which we had faced earlier was now obviously the province has opened, the country has opened, but before we had COVID-19 lab entry restrictions, we couldn't enter the lab. We also do have a safety concern when working with these setups. Why? Because we are dealing with electricity. Then there's a requirement of tools. Different relays, set test kits require different types of tools. Fault analysis is also very complicated. So what does this mean is when a fault does occur at site, you get the concrete file and then you need to figure out how you translate. You need to arrange for a test kit. You need to arrange for a relay, do the wiring, back to square one. Training would also need physical relay. So if you want to train new graduates, new students, or any new engineers, you need to train them to get them up to speed with what's happening with the protection, how the protection relay works. So for that, you need actual physical devices. Then maintenance of assets. Minute you have this minute you have devices in the lab for testing, you need to maintain them, make sure they're running from time to time, if they're healthy, not healthy. Troubleshooting, commissioning, you're stuck at site, you have a commissioning issue, and you need to figure out what is the issue. So that's another challenge. New firmwares, you have a new firmware which has some enhancements, some bug fixes. You want to test it out and see whether it actually is usable or whether it actually solves your issue. So instead of actually loading it in an actual physical relay at site or in the lab, you test it on the twin. And also logic validations. So, okay, so I'm waiting for the slide to load and it should be loaded. So Siemens Cyprotech Digital Twin Solution. So how does Cyprotech Digital Twin address these topics, these issues which you can see on the screen uh, right now? How do means what do we need to address these topics? All we need is a Cyprotech digital twin license. That's all you need to address these topics over there. So before we deep dive into how the digital twin is, the Cyprotech digital twin, how it works, how everything goes on with the application, let us first look at how a traditional protection relay works. So a traditional protection relay will have both hardware and software aspects that come together to form a protection relay. You have binary inputs, which is BI, which can be used for statuses or defining user inputs. You have CTPTs, current transformers, voltage transformer inputs, which are secondary inputs, which will be responsible to measure the actual currents and voltages in the power system. And then you have different communication modules, as you can see at the bottom, COMM, that's communication modules, which will be responsible for horizontal communication between relays, for inter-relay communication, or vertical communication, which is responsible to talk to a control center or Scada sensor. So all these external sources on the left-hand side, your binary inputs, your CTs, your PTs, your communication modules, all these external sources of information is then processed in the relay in the form of prediction algorithm or CFC slash PLC logic. So our PLC logics, we call it CFC logics. So then once it is processed in all these algorithms, then you have to get an output. So an output is nothing but a result. So the results of these outputs is pretty much processed data that is expressed by the relay through its HMI display. So your display on the relay, the LCD display, through binary outputs, through LEDs, or stored in various logs, and also communication back to the control center or the other relays by using the communication port. So that's your normal traditional protection relay ideology. So how do we achieve this capability? How do we achieve this digital twin capability? Just 4 steps. So the digital twin application is stored in the cloud and it can be accessed anytime, anywhere using a web browser. We call it the 4-step approach. Step 1 being you create a configuration using the Dixie 5 software, which is a configuration software for Siemens protection relays. Through the software, you export a configuration file in a .sim format, which has all the data for that particular relay or multiple relays. You then import the SIM file in the Cyprotech Digital Twin application, which is done via a web browser. And then you power up the relay and test to validate your results and validate how the relay is performing. So that's how simple it is. And this application, since it's web-based, it will work on any leading web browsers today: Microsoft Edge, Firefox, Google Chrome, or Safari from Apple. And as I mentioned to you earlier, since we need a web browser to access this application, it's pretty much an anytime, anywhere access or approach, because you don't need to have physical relays. Going to the next slide. So let's look at a high level UI, user interface, of how this application actually looks, what it does. So on the left hand side, as you can see, this is the UI, the user interface of digital twin. And through this tool, you are able to interact with several devices. So all these devices are loaded in the cloud, and you're able to interact with multiple devices. You're able to press the keypads and interact with them, go through the different menus. Yes, you can do that even with digital twin. You can also view all the indications on the device. So for example, if some fault some protection fault, you trigger some protection fault like 505167, the LEDs, the indication on the HMI will also appear, giving you real-time visualization of what's going on. You're able to inject process data, that is currents and voltages, and not only the magnitudes, you can also influence the phase angles and frequencies. You are also able to trigger or toggle binary inputs, and then maybe to give a status of a breaker close or breaker open, or maybe an intertripping requirement. You can do that as well. And through all these external sources in the digital twin itself, you are able to test the protection functions and logics being the CFC logics, PLC logics, which we have in the relay. And finally, we are able to replay comprate files. So CFG files, whenever a fault occurs at site, you will get a comprate file. You can load the comprate file in the cloud as well and replay it on the same relay and see how the relay behaves, make the changes, and figure out whether that solves your issue or not. So this is just a high level overview on what the digital twin can do. And now let us, if you recollect in the previous slides, I showed you how the traditional protection relay ideology works. So how would the same ideology would look on the digital twin? So on the left-hand side of the relay, traditionally you would use analog inputs or digital inputs, which is fed from a test kit. That's like an Omicron or a Mega or Doble. So this now can be replaced with simulated values using the digital twin application. As you can see, we have binary inputs simulation, and then voltage and current simulation. On the right hand side, also we have a communication protocol. So you can also receive communication signals from either a Scada system, either RTU, or either some simulated master. So you can use that as well. And finally, all this data is then processed in the same way like a normal physical protection relay would do it. It would process all this data and then output or export all this data on the right hand side, as you can see, via binary outputs or LEDs, or via the measurements, or via the logs, or via the display, or again through the SCADA. So that's how the ideology would look on the digital twin. So going to the next slide, let it load. And yeah, I think it's loaded. So let's look at the summary of various capabilities using the digital twin application. So let's look at number one. Number one is visualize and interact with the simulated device. So device operation, what do we mean by device operation? You can use the HMI, the keypad of the device, go through the different menus, go through the HMI, see the different logs, uh, interact with the device. Even though it's a virtual relay, you're able to interact with it. Analog values, you're able to inject current voltages, and then you have binary inputs and outputs. So you given the binary input, you toggle a binary input, and then you get an output. Everything will be processed through some logic or through some protection algorithm, whatever you have configured in the device. Looking at point number two, so you can do online testing and web browser. So you make logics, so you want to validate whether those logics work right or not. So you're able to do online CFC debugging, and then you want to have a proof of that logic works. So you can download the logs or the fault records if it's a protection function. You can create test sequences and play it in the relay. It's similar to like your Omicron state sequencer. So you create multiple sequences and you play it on the relay. Then let's go to the communication interfaces. We support 61850, we support 104, DNP3 TCP, Modbus TCP, and protection data interface. So what does this mean is that you can also have inter-relay communications. Both of them are on the cloud, or you can have a physical relay communicating to the relay on the cloud using a VPN bridge, or you can have the relay in the cloud communicate to a Scada system, which is on your PC, again by using VPN, or you can have it communicate to an RTU by using a VPN bridge. So multiple possibilities are available using this digital twin application. Then you can, looking at point number 4, integration into substation automation systems. So you can either integrate the actual relay in the cloud to an actual RTU, a physical RTU, which is our CCAM 8000 family, or you can report to a HMI or a SCADA system, which is a CCAM Pass or CCAM SCC or PQS. You can also communicate to third-party systems. So if you want to do 61850 goose testing with a third-party relay, you can do it, or you can report to a third party control center or a third party RTO. You can do it as well. And you can test interlockings of goose between two relays in the cloud or the relay with an actual physical relay, again by using a VPN bridge. Coming to number 5, you can do ComTrade analysis. So if fault occurs at site, the field engineers will export the ComTrade file. They'll send it over to the engineer who has access to digital twin. He will load the ComTrade file. He will have the same configuration of the relay at site. He'll be able to transplay the fault, see what exactly is happening. And by the time that engineer, if he's far away from the site, he can actually, this engineer at the local lab can actually test and validate using digital twin what could be the issue and how to mitigate it. Then documentation. Finally, everybody needs to have some documentation of the test you have done. So that can be done by test reports and logs. So you can get test reports and logs based on what tests you have done with the relay. So looking at the summary of all these applications, I have another poll question coming up, and I request if that poll question could be brought up. And yes, so you should be able to see the poll question. So we have a second poll question. So based on what I've explained today, based on all the slides you have seen, what benefits do you foresee using digital twin in your operations or your organization or any activity relating to protection relays? You have 4 options: time savings, space savings, cost savings, or the anytime, anywhere approach. Okay, so we have results coming in, and I'm just waiting for the other results to come in. Okay, so 45% of the attendees have mentioned that this would help them. Have chosen option number 4, that is the anytime, anywhere approach, which is quite handy. It's quite convenient. 9% of the attendees have chosen cost savings. 18% have chosen space savings, and 27% have chosen time savings, which is, yes, it is pretty much beneficial. So coming to that, I will pull up my next slide, which shows the benefits of digital twin. So benefits of digital twin is pretty much what you all have already identified. And the customer value proposition which we have over here is that you do not need hardware, and you can set up your system within minutes and without any additional effort. And the most important part is the anytime, anywhere approach. So even if you're sitting maybe at an airport and you're going to go to the site and you need to figure out what is going on at the site, digital twin, open, start the relay, test it, and you're good to go. So Few of the benefits I wanted to point out. So you have simulation and validation of product properties. That is the settings, what you configure in the relay, the algorithms, the logics, the communications. Faster energization of new systems thanks to shorter project timelines. Since you already have this tool, you do not need the physical relay to test all the functions of the tool. Hence, your engineering quality will improve. You foresee any challenges you would meet before commissioning. You would meet it while doing the testing at that point of time, and hence would result in shorter commissioning time. So since you're already well prepared beforehand, it will result in shorter commissioning times, better quality, and quicker resolution of issues. Then you have reduced to OPEX with shorter outages for higher availability thanks to better pre-testing. You have efficient, scalable trainings on the job. You have new engineers on the job. You want to train them up with this tool. Everybody has digital twin access and they're able to test the relays without the need of physical relays and checking when the Omicron is free, when that relay is free. No, you have that's the anytime, anywhere approach. And then fast and realistic fault analysis by easily reproducing the behavior of products and systems. So this relay will behave exactly as a physical protection relay. It will run the same algorithms as a physical protection relay. So if you want to reproduce a fault behavior, you will reproduce it for sure by by using the comtrait file which you have got from the site. So I have a lot of use cases, but I wanted to point out one use case which is a very strong use case, very strong image. On the left hand side, you can see that I have an actual replica, a lab replica of a digital substation. You can see all those Protect 5 relays, maybe 15, 20 relays on the racks, all are powered up, all are wired, and all of them are used to replicate any on-site conditions. But that all can be reduced, or that call can be uh, replaced by just using digital twin. So that's a very uh, powerful use case. What we have more use cases like comtrade file replay and lab efforts. We have a lot of use cases, but this use case pretty much compiles all the use cases together and shows us how we can address this by using digital twin. Thank you. So we have the question and answer session next. So if you have any questions.
Awesome. Thank you very much, Paul and Kabir, for that presentation. Very detailed and insightful. Kabir, if you'd like to join us on screen as well for the Q&A, we can begin that session. A reminder to our audience, if you do have any questions, please use the questions function on your screen as shown by the slide here, and I'll ask your questions to our presenters as they come to mind. To kick off the session, perhaps Paul or Kabir, you guys could start off by talking about how many relays can a digital twin simulate?
So since this is a cloud-based application, there is no limit, but it's limited by a license. So the digital twin has multiple license variants, which allows you to have run maybe 2 relays, maybe 5 relays, maybe 10 relays, maybe 20 relays. So you can choose to run multiple relays at a time, but it depends upon what type of license you use.
Excellent, thank you very much. And how many analog signals can I perhaps simulate for each relay?
Perfect. So let's take an example where I have maybe a busbar protection relay. I have 24 channels of currents coming through. I can simulate all 24 channels of currents with respect to the phase magnitude, the phase angle, and the frequency. So I can change any of the 24 analog or current inputs and use it however I want. So it's not limited to any factor. It depends how many inputs the relay actually has when it comes to CT, PTs, or BIBOs or BIs. Sorry.
Understood. Thank you. And folks wondering, how could they visualize the event logs in real time?
So whenever the relay, so it's actually equal to a physical relay. So you as good as a physical relay, how you would normally visualize the event logs. You either use the Dixie software, and you access the relay in online mode and download all the logs and visualize it, or you can check the HMI of the relay in the cloud. Or there's another option that's available in digital twin that automatically shows all the event logs while you're testing the relay. So it's available, and there are 3 methods. You can choose any of the method, whichever you're comfortable with.
Awesome, thank you.
Yeah, Farhan,
Sometimes,
just to
yes, go ahead.
sorry, I just wanted to compliment what Paul said, just to tie off to your question as well. You know, when we look at the digital twin as a solution, as a software, it's pretty much standalone, right? In the sense that you don't need the hardware. So imagine if you have a project or a system with multiple set of relays, and depending upon how many relays you got, you can have the licenses accordingly. So you can decide based on your requirements how do you want to use the digital twin. The best takeaway I would always say is in this time and age, particularly as we see many people work from home, and you talked about in the start of the presentation as well. I mean, you don't want to invest on something, and you can always do that by testing off before buying the hardware. So that's the best part of it. You test and validate, and you make sure your design is all good, and then you can really think about buying the hardware in the future. So whole thing is like a sort of getting up and ready, making sure your design, your planning makes sense by testing and validating the solution using digital twin. So I would say really the cost versus saving benefit lies really down to the fact is that if you have a project in your mind and you're not sure whether it makes sense to go on a engineering phase or a planning, a design phase, maybe you want to pre-validate this with a solution. So get it up and running. And this is exactly one of the main driving points, using our Ciprotech digital twin. I just wanted to highlight that point and emphasis a bit more, because time and again, I have seen from our feedback coming from our customers or consultants, engineers, so on and so forth, is that they want to save time. Of course, they want to save money as well, but also the time, especially in this day and age when we have this pandemic going on as we speak.
Awesome, thanks for adding that in. So I have some more questions coming in from the audience. Sometimes specialized testing are required using RTDS. Have you had any experience with RTDS and this tool?
So we do not have RTDS with this tool. I will have to check and see. But how we test normally, we can test in 3 ways. You can actually test like how you test using Omicron Quick CMC. You put the values of currents and voltages and then just give a start and see how the fault occurs. That is one way you can test. The second method you can use to test is you create a state sequence file using the Omicron state sequencer. So you have multiple states. You create a pre-fault state, a fault state, and then after a false state. So that's the second way you can test it. Or you can actually generate a comprate file with harmonics, with whatever external influences in the system, like DC offset harmonics, and actually translate in the relay and see how the relay behaves. So to answer your question, RTDS, I have not worked with it, but these are the methods which we use to actually test in the relay. If the RTDS can export maybe a complete file, having the external factors, then definitely you can replay it in the relay and see the result, how it is, for sure.
Great, thank you. Next question is, if I purchase an account, for example, a small one for 2 relays, does it mean that I can use it for specific 2 different MLFB?
Good question. Very good question. So take for example, if you had to buy 2 physical relays, then you're stuck with those 2 physical relays forever, pretty much. Whereas if you use digital twin, you can use any MLFB, any 2 MLFBs. So if I want to test a 7SJ today, I can test it. If I want to test a 7SS tomorrow, I can test it. I can add and remove the relay whenever I want, and as long as there's a limit of 2, and I don't exceed that limit, then I'm good to go. So physical relays, you would need 2 relays. You're stuck with those 2 relays. When you're using digital twin, any relay you can use as long as it's 2 quantities. You can boot up both those relays at the same time and have interwiring test or intercommunication test. So that's the advantage of digital twin over having physical relays. And you do not pay for additional hardware or additional relays. So if you make a new MLFP part number, you don't pay for it. You have that license. That license supports 2 relays, any of those relays, any part number within the Cyprotec 5 family. We have the compact Cyprotec 5 compact also released now, so that also will be supported. Apart from the non-modular and modular series of Cyprotec 5 relays.
Thank you, Paul. Also have a question regarding pricing. So how much does it cost for purchasing an account? I don't know if you're able to disclose that, or we can share that with the audience member after the session. Are you able to share anything about that one?
So right away, we would have to investigate and see what licenses the user would need. And we normally recommend what type of license she should go ahead with, because different licenses have different features. You have Comtrade replay only available with M license. You do not have that with S license. So probably after this session, we will reach out to the interested party, and then we will address that question for sure.
Thank you. That makes sense. All right. Seems that we've run to the end of the questions. Again, I'll ask the audience if you do have any questions. We have a little bit of time. I can ask them of our presenters. In the meantime, Paul or Kabir, do you have anything else perhaps that you'd like to leave our audience with, final thoughts or anything that you'd like to mention?
Yeah, I mean, look, I would add on a couple of things. One is, think about this as a backup trump card in your pocket. When you are looking at a project, you've got to think about whether you want to make investment on hardware, want to make some savings on time. So this exactly is one solution. The other aspect is also, which I want to highlight, is as you look into this portfolio of digital twin, we might realize Siemens, as Siemens business unit, we can also support with other offerings from our basket. So as you use this tool, to test and validate, and then you realize, oh, by the way, I may need to buy the real hardware, or I may need to buy the switch gear, or I might need to buy other portfolio. We can do this complete holistic offering, which we can help you support from what I would say wing to wing, a complete solution. So yeah, I mean, whether it's a product, whether it's a software or it's a hardware, what are your needs and what are your project needs? And we can help design a solution. If we realize that, okay, maybe you just need a tool to test, you have a digital twin. Maybe after the tool is tested and validated, you realize you need a hardware, we can support with that as well. So yeah, this complete 360-degree view of the solution we have in our portfolio. And this is the takeaway I would really recommend to any of the clients or people attending this session today, engineers, utilities, consultants, EPCs, and all of them. Reach out to us. Tell us your requirements. What are they? What are your requirements? And we can suggest to you which is the best approach. And you can decide whatever you want to decide end of the day. But we can give you some recommendations based on what are the project needs.
Excellent, thank you, Kabir. I did have actually one more question come in as you were mentioning that. So can I simulate the system interface signals to a simulated SCADA system to ensure the correct mapping?
Yes, you can do that. So how do we do that is by using a VPN interface. So a VPN is nothing but a virtual private network. It's a tunnel which will be on a local PC. So normally you're simulated. So if you look at ID Scout, it's a simulation type of software, so 61850. So the PC that will be housing ID Scout will be connected to the relay in the cloud using a VPN client, Soft Ether, if I'm not wrong, that's the name of the VPN client. And then the communication happens between the simulated PC, the simulated software. It can be ID Scout or maybe mod scan or something, any simulated software, and then you can send it to the relay in the cloud. The communication happens with the VPN, and then the relay will respond based on whatever command signal you have and respond back to the maybe the simulated client, the Scada simulated client. Let's talk about ID Scout, and it will show the result as well. But you need a VPN client. Definitely, you need a VPN client to see how the signals work.
Excellent, thanks, Paul. So yeah, with that, I think we've reached the end of our Q&A portion. So we'll conclude the session here. I'd like to thank you again for taking time to answer those questions and for that wonderful presentation. All of our future events and webinars can be found in our monthly newsletter, again, on current affairs, or you can go to the events section on our brand new website, again, at electricity.ca, to see what else we have coming up. In closing, thank you again to Siemens, Paul, Kabir, and each of our audience members for joining us today. That concludes today's session. We'll talk to you next time, and stay safe. Bye for now.
Thank you.
Thank you. Bye-bye.
Bye.